Hey guys, in this video I'm going to show you how to use Tracker, which is going to come in handy for different labs that we do throughout this year. So to begin, I'm going to make sure I have the ball drop video and the motion pre-lab downloaded from the hub. I need both these things to do the pre-lab, obviously. And then I'm going to come to my Windows search tool and I'm going to type in Snipping Tool, S-N-I-P-P-I-N-G. Right-click this and hit pin to pin to taskbar. So now it comes up right away. You're going to need this to insert copies of your graph into the Word documents. Then you're going to go to the Software Center. The Software Center should be on your desktop. If it's not, again, search it in the Windows tool. Searching for the Software Center. It only works on HIC's campus. I mean, you can see the applications you can download, but you can only download if you're at Lamar High School or another campus. So you're going to type the app that we're using to track. It's called Tracker, T-R-A-C-K-E-R, Tracker Software. Search it. I already have it downloaded to expedite the process, and it looks like this app. So you're going to click to open Tracker. Comes right up, and you need to make sure your Zuggle is up to date. So if it isn't, you won't be able to see video in Tracker. You need to go to either check for upgrades. It's diagnostics, that's right. Diagnostics under help, diagnostics about Zuggle. If your Zuggle is updated, it will look like this. If not, it will tell you click OK to configure Zuggle or something like that, enable Zuggle. Okay, now for those of you who have Apple or iPhones, you need to make sure that when you make your videos, you save your videos as a .mov or a .mp4. I think iPhone uses a different application or a different file extension, maybe a .gp4 or something else like that. It won't open, so it needs to be a .mov or a .mp4. Very important. Now I'm going to go to Open File, and most likely you downloaded this from the hub, so it's in your Downloads folder. Mine I put on my desktop, so I go to Desktop, balldrop.mov, and Open, and here it is. We're about to start analyzing one of the two balls that he is dropping in his hands, and they'll fall towards the earth as objects tend to do. We always start in Tracker by moving the black arrow, this lower black arrow, over until the balls begin to move. Just as they're being released, bam. Now you can see that there are two little spheres starting to form. I'm only going to track one of these two. I'm going to choose the top one, but you can track the bottom one. Good. Now that this black arrow has been slid over, we're going to then create a coordinate system. We're going to calibrate a distance. In here, there is a 1 meter long white bar, so we are going to calibrate the distance for our tracking software. Going to this tool, you see the little number 10. Go to New Calibration Stick, and it says N1 shift click to mark. So I'm going to start from the bottom because that way my angle will be positive 90 degrees. So I hold down Shift and I click the bottom of the meter long bar. And if I hold down Shift, you can see these little crosshairs come up, and I click the top, and I need to change the distance from 424 meters or whatever to 1.0 meters. And then this has told the software how far this ball is moving in this amount of time. If I click where it says calibration stick A and I click off visible, it's no longer in my way, but it still shows 1 meter in length and about a positive 90.1 degrees. So it should really be 90 degrees from the x-axis. And notice that I did that. The next thing popped up, the coordinate system. So after you have your calibration stick set to 1 meter and you've hidden its visibility, you go to this, show or hide the coordinate axis, and you want to grab the center, the origin, and you place the origin right in the middle of the ball that you'll be tracking. If you grab this vertical line, it rotates. If that's the case, no big deal. Just make sure you rotate back until the coordinate system is again at an angle from the horizontal of 0 degrees, and I click this off to hide. Now we're actually going to start tracking the ball as it falls in the y direction towards Earth. I'm going to go to Create, Point Mass, and keeping this tracking control clicked on and active, has to be an actively clicked window. I hold down Shift and I click the center of the ball that I'm going to be tracking. Shift click, Shift, click. I'm still holding down Shift and click, going. And you can see as I'm doing this over here on the right, it's plotting the X direction, the units meters against time in seconds, holding down Shift, click, Shift, click, Shift, click, Shift, click, all the way down. I'm trying to keep mostly aligned in the center of this object until it's out of frame. Good. Now I've plotted this, and you can see that this little graph looks really disjointed, and it should look like that because this ball is mostly only moving in the Y direction, the vertical direction. Any deviations coming from the X direction are most likely a result of maybe some wind, some fluid dynamics, or even just my own tracking ability. I might be skewing a little bit, but that's okay. So you go into the Word document and you see it says insert a copy of the X versus T graph in the space below. So I will do just that. I will go back into Tracker, and you right-click your video and you go to Analyze. So I right-click, scroll down to Analyze, and this screen pops up. It's a big version of the graph. I go to Analyze again and I make sure curve fits are set. I'm just going to use a line graph. The fit equation X equals A times T plus B. This is what I plug in. I plug in the A value here. To this A, I plug in the B value here. Now this is where the snipping tool comes in because I'm going to take a screenshot of all of this. I don't care about the table over here. I'm just going to screenshot this and the fit equation. So I go to my snipping tool, pops up, go to New, and I'm just going to slide across and highlight. Everything else turns gray on my screen. You'll see. I'm not sure if my web recorder can record this, but I have now just taken a snapshot of this image, and it automatically copies to my clipboard. So I will now go to Control, hold down Control V, and it pastes a copy of this graph into the Word document. What is an equation for this line? This line is X, that's the position in the horizontal direction, equals A. My value for A is that negative 2.435 e negative 2 times t, because this is my independent variable is time, plus my y-intercept is negative 3.336 e negative 3. Now you remember the equation for the y equals mx plus b, the slope-intercept form of the equation, where y is my vertical axis, x is my horizontal axis, m is the slope, b is the y-intercept. In this case, my vertical axis is the x position in meters. My independent variable is time. My slope is my y-intercept is this b value, and the slope is the a value, the negative 2.435. This graph should look pretty crazy because the ball really isn't moving in the x direction. Next it says, what does the slope of this line tell you? Remember, the slope of a position versus time graph is velocity. In this case, this is the velocity in the x direction, meaning the horizontal direction. Now I want you to insert a copy of the y versus t graph in the space below. So we'll come back here, we'll close this out, that other data analysis tool, coming back to our main tracker screen, and if I click this vertical axis label, I can change it to the y position versus time. And look at that, it's a nice parabolic curve. So I right click, again, analyze this data, tool window pops up, but notice it has both the X, the Y, and a T. I want to get rid of the X column, so I right click and go to cut the column, and now I'm just looking at Y versus T. But this is not a line. The fit is a parabola, so I'm going to change the fit name from line to parabola, and always auto fit is selected. So now you can see this comes up really nicely, and it's in y equals a squared, a t squared plus bt plus c. That's a parabola. So again, new, take a screenshot of all this, and I'm going to paste it into the space below. Control paste. That looks great. Why is the y versus t graph a parabola instead of a line? Okay, I'll go ahead and give you the answer for this one. Because the object is accelerating in the y direction. Whoops, I can spell. Okay, insert a copy of the v sub y versus t graph in the space below. So I'm going to make space for this. scrolling down. I'm going to insert a copy of the graph. So I go back. I'm going to close out my data tool window. I'm going to change this from y to the v sub y. It's almost a perfect line. Right click, analyze again. Get rid of my y column by right-clicking it, cut the column. I'm going to change the fit name from parabola back to a line. Auto fit is selected, and boom. I have this value, negative 9.095 for my slope. You should be getting something around negative 9 or negative 10 because this slope value tells you the acceleration of gravity. So I'm going to go again, my snipping tool, new, grab all this, control paste it into the Word document. You're going to copy the equation for this line again. V to get the subscript, you go control plus. That gives you a subscript. Control plus again takes you out. And by the way, if you want a superscript or an exponent, if you go control shift plus, this gives you an exponent. We don't need that right now. My equation for this line is negative 9.095. Notice that's E0. That just means times 1. I don't need to include it. Times T minus, because that's plus B, but in this case it's a negative plus a negative, so I'm just going to do minus 4.085 E negative 1. I could also have typed that like a decimal place. What does the slope of the V sub y versus t graph tell you? It tells you the acceleration in the y direction. And the true value should be around negative 9.8 meters per second squared. This is the true value for acceleration near Earth's surface, and this is a value that you need to get close to in your labs. So I hope you found this video helpful, and you will be using this software several times. No matter who shoots the video, everyone in the lab group is using the tracker software to analyze. Okay, so I hope you found this helpful, and thanks for watching.